Hello students, today we are going to discuss thermal expansion problem. An iron bowl is heated, the percentage increase will be largest in. Dear student, in thermal expansion alpha, beta, gamma remains in the ratio of 1:2:3. So volume expansion remains maximum. Okay. So out of 4 options, the correct option is option 3. Two holes of unequal diameters D1 and D2 are cut in a metal sheet. If the sheet is heated, then what will happen? Dear student, thermal expansion is simply photographic enlargement. If these are two cut, then definitely D1 and D2 both will increase. If temperature increases, then D1 will also increase and D2 will also increase, as if it could have made as the actual sheet. Okay. So out of 4 options, the correct answer is option 2. Both D1 and D2 will increase. Two rods of length L1 and L2 are made of material whose coefficient of linear expansions are alpha 1 and alpha 2. If difference between two lengths is independent of temperature, dear student, this is the equation of change in length. If the difference between two lengths is independent of temperature, means change in length must be same. Okay, so L1 alpha 1 should be equal to L2 alpha 2. So L1 upon L2 must be equal to alpha 2 upon alpha 1. So out of 4 choice, the correct choice is option 2. This is a very good question in thermal expansion. Can be expected in NEET or JEE 26. Okay. The coefficient of linear expansion of steel and brass are 11 into 10 power minus 6 per degree centigrade and 19 into 10 power minus 6 per degree centigrade respectively. If their difference in length at all temperatures has to be constant at 30 centimeter, their length at 0 degree centigrade should be. We know with the increase in temperature, length increases. Alpha 1, alpha 2 are given. Difference is kept constant. Okay. Their difference in length at all temperature has to be kept constant at 30 centimeter. The difference should be 30 centimeter. Okay. Dear student, since coefficient of expansion for steel, alpha steel, is given 11 into 10 power minus 6 per degree centigrade, and alpha brass, this is given 19 into 10 power minus 6 per degree centigrade. Since length should be constant, so delta L should be same. What is delta L? L steel, alpha steel, delta theta equal to L brass, alpha brass into delta theta. Cancel delta theta on both sides. We will get L steel, alpha steel means 11 into 10 power minus 6 equal to L brass, alpha brass equal to 19 into 10 power minus 6. Now cancel 10 power minus 6 on both sides. We will get 11 LS equal to 19 lb. This is equation 1. And now difference of length should be 30 centimeter. Okay. Now we can say LS minus LB should be 30 centimeter. Now we can solve this equation and can find result. So LS equal to what? LB plus 30. So 11 LB plus 30 equal to 19 LB. After solving this, we get 11 LB plus 330 equal to 19 LB. 8 LB equal to 330. After solving this, we get LB equal to 330 upon 8. This is 41.25 centimeter. So what is LS? LS will be 71.25 centimeter because LS minus LB is 30. Okay. So out of 4 choice, the correct choice is option 1. Dear student, out of 4 choice, the correct choice is option 1 in this question. So this question you should study very carefully. And why we have done LS minus LB equal to 30? Why we have not done LB minus LS equal to 30? Because LHS value should be equal to RHS value. This 11 is less than 19. So LS should be more than LB. Then only equation will get balanced. Okay. A metallic bar is heated from 0 degrees centigrade to 100 degrees centigrade. The coefficient of linear expansion is 10 power minus 5 per Kelvin. What will be the percentage increase in length? Dear student, coefficient of linear thermal expansion is given as delta L upon L, delta theta. This is the equation. So delta L upon L into 100 equal to alpha delta theta into 100. So after solving the equation, we will get alpha is given 10 power minus 5. Delta theta is given 100. This is 100. So this is 10 power minus 1. After solving this, we will get 0.1%. So out of 4 choice, the correct choice is option 2. So we will tick option 2 is the correct answer. A metal wire of length L and area of cross section A is fixed between rigid supports at negligible tension. If this is cooled, the tension in the wire will be. See, dear student, what is Young modulus which is defined for solid? This is delta L. This is F upon A, stress upon strain. So F upon A equal to Y into delta L upon L, that is Y alpha delta theta. So F that is equal to tension equal to what? Y alpha delta theta into A. So in this equation of tension, it is independent of length. Okay. So out of 4 choice, the correct choice is option 3. So we will take option 3 as the correct answer. So here option 3 is the correct answer. What will be the stress at minus 20 degrees centigrade? If a steel rod with a cross-section area of 150 millimeter square is stretched between two fixed points, the tensile load at 20 degrees centigrade is 5000 Newton. Dear student, now we can calculate stress at 20 degrees centigrade. Stress equal to what? Force upon area. stress at 20 degrees centigrade. This is force and this is area 150. Millimeter square means 10 power minus 6 meter square. So this will become 5 upon 15 into this is this 0 will get cancelled. This is 10 power 8. 5 upon 15. Okay. So 1 upon 3 into 10 power 8. So this is 33.33 into 10 power 6 Newton upon meter square. This is the stress at 20 degrees centigrade. Due to decrease in temperature, stresses will come into picture. So change in stress will be equal to 33.33 into 10 power 6. Change in stress can be calculated as, see here, the formula is y equal to what? Stress upon strain. And so stress can be written as y alpha delta theta. So change in stress can be written as y is given 2 into 10 power 13 and alpha is given 11.7 into 10 power minus 6 and delta theta is 40. We have to take magnitude, okay? So this will come 2 into 4, 8, 8 into 11.7 into 10 power 7, 13, 2 into 4, 8. This will be 10 power 8. 10 power 13, 10 power 14, okay, 10 power 8. 2 into 4, 8, 8 into 11.7. So after calculating this, you will get approximately 88 into 10 power 8. This is 2 into 10 power 13 into 11.7 into 10 power minus 6 into 40, okay. So 10 power 13, 10 power 14, 14 minus 6, 8, okay, 8. We have already taken that power. So 2 into 11.7 into 4, this is 2 into 4 into 11.7 into 10 power 14 minus 6, 8. So this is approximately 88 into 10 power 8. We have to check this again. This Young modulus value is wrong. This is not 200 into 10 power 11. This is 2 into 10 power 11. This value is wrong. Young modulus value is not this. This value is 10 power 11. If it is 10 power 11, 12, 10 power 6. So 2 into 4 into 11.7 into 10 power 12, 10 power 6. So this is approximately 88 into 10 power 6. Then only total stress at minus 20 degrees centigrade will come. Initial stress plus final stress. Okay. Newton upon meter square. So Final answer will be 127 into 10 power 6. Okay. Let's recorrect. Let's resolve this question again. Okay. Let's resolve this question again. Let's restart this question again. First, make this data to be correct. This is 2 into 10 power 11. What will be the stress at minus 20 degrees centigrade if a steel rod with a cross-section area of 150 millimeter square is stretched between two fixed points? The tensile load at 20 degrees centigrade is 5000 Newton. Dear student, due to change in temperature, thermal stresses come into picture. Now, tensile load at 20 degrees centigrade is given 5000 Newton. So, we can determine tensile stress at 20 degrees centigrade. How? Force upon area. So, first calculate tensile stress. At 20 degrees centigrade. This is equal to force 5000 upon area, that is 150 millimeter square. We are converting millimeter to meter, so this is 10 to the power minus 6. So 0 will get cancelled. So this is 5 upon 15 into 10 power 8. So this is 33.33 into 10 power 6 Newton upon meter square. This is the initial stress at 20 degrees centigrade. Okay. Now, due to change in temperature, we are looking at the equation of Young modulus. Young modulus is stress upon strain. So, thermal stress will be equal to change in thermal stress. Change in thermal stress will be equal to y alpha delta theta. So, dear student, in the question, y is given 2 into 10 power 11. Alpha is given 11.7 into 10 power minus 6. And change in temperature, we have to take modulus, that is 20 minus 20, so 40 degrees centigrade. Okay. So after solving this, we get 22 into 4, 8. 8 into 11.7 into 10 power 11, 12. This is 6. So this equation will give us 5, 13, 93.6 into 10 power 6 Newton upon meter square. So the final stress at minus 20 degrees centigrade will be equal to initial 33.33 plus 93.6. This is the final stress. So approximately we can see this is 127 into 10 power 6 Newton upon meter square. So this is our final answer out of 4 options. Out of 4 options, dear student, the correct answer is option 3. Among 4 choice, the correct choice is option 3. This is a very good question for NEET or JEE 26. Okay. If a bimetallic strip is heated, it will. When a bimetallic strip is heated, it bends towards more alpha. If alpha 2 is greater than alpha 1, if temperature is increased, when temperature is increased, this will be like this. It will bend towards more alpha, okay? Bend towards the metal with higher thermal expansion coefficient. So out of 4 choice, the correct choice is option 2. So we will take option 2 as correct answer. The temperature of a pendulum, the time period of its t is raised by delta t. The change in time period will be, dear student, time period do not change in the time will be, in this question the change in time when pendulum clock is taken in the hot country, that change in time is half alpha delta theta into time interval. Half alpha delta theta into time interval. So this is the answer. Option 1. Out of 4 choice, the correct choice is option 1. Here, delta t is the time interval. Remember, in hot countries, clock loses the time. In hot country, clock loses time. And in cold country, clock gains time. So out of 4 choice, the correct choice is option 1. This is a very good question for NEET or JEE 26. A pendulum clock is 5 seconds fast at temperature of 15 degrees centigrade and 10 seconds slow at a temperature of 30 degrees centigrade. At what temperature does it give the correct time? Let us assume at theta degree centigrade the pendulum clock is given correct time. See, it is 5 seconds fast, means it is in hot country. So this is gain of time, half alpha delta theta means theta minus 15 into delta t is the time interval. Now in the cold country, it will lose the time and 10 seconds slow. In the hot country, it will lose the time. 10 seconds slow, it will lose the time means this is not 5. This is 10. 10 seconds slow. This is not theta minus 15. This is theta minus 30. In hot country, it will lose the time. 30 minus theta into time interval. In hot country, it will lose the time. And in cold country, it will gain the time. So gain is time equal to 5 half alpha theta minus 15 into delta t. So dear student, let's divide these two equations. After dividing these two equations, we will get 10 upon 5, 30 minus theta upon theta minus 15. So this is 2. How 2? Because it will get cancelled by 2. So 2 theta minus 30 equal to 30 minus theta. So 3 theta will be equal to 60. So theta equal to 20 degrees centigrade. At 20 degrees centigrade, this will give the correct time. At 20 degrees centigrade, this pendulum clock will give the correct time. So out of 4 choice, the correct choice is option 2. This is a very good question for NEET or JEE 26. A pendulum clock has an iron pendulum 1 meter long. Alpha iron equal to 10 power minus 5 per degree. If the temperature rises by 10 degrees centigrade, the clock will. Dear student, loss or gain of time do not depend on the time period. So no need to calculate time period by 2 pi into L upon G. Simply, if the temperature increases, it will lose the time. So loss of time equal to how much? Half alpha, that is 10 power minus 5 into delta theta, this is 10 into delta t per day. Per day means 86,400. Now, if we solve this, this is 10 power minus 5. So this is 10. This is 10 power minus 4. And this will become 8.64. Okay. So 8.64, this will become 4.32 second. So it will lose the time. Will lose 4.32 second per day. So out of 4 choice, the correct choice is option 2 is the correct choice. Remember, in hot country, it will lose the time. When temperature will increase, it will lose the time. So answer 2 is the correct answer. It can give you 1 plus question, okay, in NEET or JEE 26. A second pendulum clock having steel wire is calibrated at 20 degrees centigrade. When the temperature is increased to 30 degrees centigrade, how much time does the clock lose or gain in 1 week? In 1 week, the loss or gain, because temperature increase, it will lose the time, half alpha delta theta into delta t. So we can write half alpha. Alpha is given 1.2 into 10 power minus 5. Delta theta, change in temperature, increase in temperature, 30 minus 20, this is 10. And 1 week means 7 day, 1 day equal to 86,400 seconds. 86,400 seconds. After solving this, we will get, this is 0.6 into 7 into 8.64 into 10 power 4 into 10 power minus 5 into 10. So this complete figure will get cancelled. Okay. This is 4.2 and 8.64 second. Now 8 into 4, 32. It can be seen. The option is 36.28 second. No need to further solve because this is objective question. Okay. So answer is 36.28 second. So out of 4 choice, the correct choice is option 4. Out of 4 choice, the correct choice is option 4 in the question. This is very good question for NEET or JEE 26. If the length of a cylinder on heating increases by 2%, then area, dear student, the areal coefficient of thermal expansion is twice the linear thermal expansion. So it will increase by 4%. How? Delta A equal to A beta delta theta. So correct choice out of 4 choices, option 4. Option 4 is the correct answer in our case. A solid ball of metal has spherical cavity inside it. The ball is heated, the volume of cavity will. Definitely volume of cavity will increase if the ball is heated. Out of 4 choice, the correct choice is option 1 because thermal expansion is just like its photographic enlargement. If alpha, beta, gamma are linear, superficial and cubical expansion of solid, then alpha, beta, gamma equal to 1:2:3. This is standard result. Out of 4 choice, the correct choice is option 1. The volume of solid decreases by 0.6% when it is cooled through 50 degrees centigrade. Its coefficient of linear expansion is, dear student, we know gamma coefficient of volume expansion is 3 times coefficient of linear thermal expansion. Gamma can be written as change in volume per unit change in temperature. Since delta V upon V equal to gamma delta theta, this is given in the question 0.6%. So gamma into delta theta, this is 50. So value of gamma will be equal to 0.6 upon 50 into 100. This is 6 upon 500 into 100. This is equal to 3 alpha. So alpha will be equal to 6 upon 3 into 500 into 100. This is 2. So this is 2 upon 5 into 10 power minus 4. So this will become 0.4 into 10 power minus 4. 4 into 10 power minus 5 Kelvin. 4 into 10 power minus 5 Kelvin. So out of 4 choice, the correct choice is option 4. Dear student, out of 4 choice, the correct choice is option 4. Option 4 is the correct answer. Which of the following curve represent variation of density of water with temperature base? This is very good question. Between 0 to 40 degrees centigrade, water behave जैसे anomalous behavior, okay? And its volume coefficient of expansion is negative. So at temperature 4 degrees centigrade, density remains maximum. So out of 4 choice, between 0 to 4 degrees centigrade, when temperature increases, it contracts. Okay, so density increases. Out of 4 choice, the correct choice is option 4. Option 4 is the correct answer. Between this is very good question. Density of substance at 0 degree centigrade is 10 gram per cc. At 100 degrees centigrade, its density is 9.7 gram per cc. The coefficient of linear expansion of the substance will be. Dear student, now let's see. At 0 degree centigrade, density is given. At 100 degree centigrade, density is given. This is density at 100 degree centigrade. This is density at 0 degree centigrade. Density at theta equal density at 0 upon 1 plus gamma delta theta. If we solve this equation, we will get 1 plus gamma delta theta equal to 10 upon 9.7. So gamma into 100 will be equal to 10 upon 9.7 minus 1. This will give 10 minus 9.7 means 0.3 upon 9.7. So gamma will be equal to 0.3 upon 9.7 into 1 upon 100. So what is alpha? Alpha equal to 0.3 upon 3 into 9.7 into 100. So dear student, now you can see this will get cancelled by 0.1. If we take this as a 10, so this is 10 power 3, so answer will become 10 power minus 4. So correct answer is option 4. So out of 4 choice, we will mark option 4 is the correct answer. A rectangular block is heated from 0 degree centigrade to 100 degrees. The percentage increase in length is 0.1%. What will be percent increase in volume? If it is a cubical shape, then definitely it will be 0.3%. But in the question, it is given rectangular block. Okay. Definitely some height will be there. So we can take 0.3% out of 4 choice. The correct choice is option 3. We have assumed this block like this. Rectangular shape. A thin copper wire of length L increases in length by 1% when heated from 0 degree centigrade to 100 degree centigrade. If a then copper plate of 21 by 1 is heated from 0 degree centigrade to 100 degree centigrade, percentage increase in its area, definitely it will be double because it is as percentage increase because beta equal to 2 alpha. So answer is option 2 is the correct answer.